on to the exercises. I'm going to read in the flights data set. Number 1, create a series of Booleans determining if there is a carrier delay of 15 minutes or more. The value should be false if under 15 minutes and true if 15 minutes are over. Okay, let's just go ahead and do that. So we'll do flights carrier delay. Is it greater than 15? Really greater than equal to 15. All right. And then find the average distance flown by each group. Okay, so we're going to do flights dot, we're going to group by S over here. We are then going to get the distance and we'll do the mean. So this is a chance to group by another series. So we're creating this grouping, right? It's either false or true. So if there's a carrier delay less than 15 minutes, this is the average distance. If there's a carrier delay greater than 15 minutes, this is the distance. So this is sort of testing to see if there's any relationship between, a delay and the distance of the flight. So they are pretty similar distances. All right, number 2, create a series of Booleans determining if there's a weather delay of 15 minutes or more. Compute a cross tabulation of this series with the similar one you created above on carrier delay. So we'll just call this S2. And we'll say flights weather delay greater than equal to 15. So a cross tabulation, let's do cross tab. So index equals S1, columns equals S2. This is not S1, it's just called S. All right, so, okay, this is a little interesting. So what this is saying, so when the carrier delay is less than 15 minutes, we get this distribution over here on, so when the carrier delay is less than 15 minutes, so by and large, most things have a low carrier, or less than 15 minute carrier delay and less than 15 minute weather delay. There's very rare both of these are true. So when the carrier delay is, you have to kind of look at the percentages over here. When there's no carrier delay, then this is a pretty large ratio. It's probably better to do some sort of, to do some normalization over here. So let's go ahead and do that. And we'll keep this whole number, and then we'll go down here. And we'll normalize across the rows. It's very tiny, so round it to 4 decimal places. I should multiply by 100. Okay, so is there some kind of relationship here? So when there's no carrier delay, there is a slightly higher chance, 0.84% chance, that there will be a weather delay. If there is a carrier delay, the weather delay will be a little bit lower. So there might be some relationship over here between weather delay and carrier delay. It's kind of hard to tell with just this one cross tabulation, but it's kind of interesting what you can do just by creating data on your own and then doing some cross tabulations. All right, number 3, find the total carrier delay by airline and origin as a series with a multi-level index. Okay. So flights dot group by airline and origin. We want this as a series carrier delay, the total carrier delay. So we're going to sum this up. So this gives us our multi-level index. We'll assign this to S over here. And then it says, using the series from exercise 3, calculate the total carrier delay by airline. Okay, so we're going to use this. So we're going to group a series here, which I said you can do by passing in the index as like the column you're grouping. Okay, so you calculate the total carrier delay by airline. So now we're going to sum up all of these values per airline. And then it says to verify this using the data frame directly. Okay, so we can certainly do that. So group by airline. We're going to get the carrier delay, and then do dot sum. So this should be the exact same. We see there, we do get the same numbers. All right, number 5, read in the Sweden deaths data set found in the COVID folder. Place the year column in the index and then calculate the total number of deaths by 10-year age interval. Okay, so go ahead and read this. Read CSV, COVID, Sweden deaths, and put the year over here. Let's call this DF. All right. Then calculate the total number of deaths by 10-year age interval. So we're going to do that same thing that we did in the last section. And so we just need by 10-year age interval. So we need to cut these columns, df dot column. Let's just look at these real quick. They are strings, so we have to convert them to integers. And then we can cut this. We'll say pd dot cut and do this by 10-year age intervals. So 0, 10, 20, 30. 90, 100, 110. So the last one is, actually it's 100. And so we can do this. So it's inclusive of 10, but it doesn't include 0. So we need to say something like include lowest equals true. So the first one will be 11 years. You can see there's a missing value. That's because 0 is not included. Or you can change it to lowest or right equals true. Either way. Actually, let's just do that. Right equals true, and this will have to be 100 and, sorry, right equals false. All right, so now it should work out. Yeah, it's got to, the right has to be 100. So the last one will actually be more. It'll be 90 to 100. And actually that 100 category corresponds to 100 or more. So it's already more than that. But anyway, it's close enough to 10-year intervals here. We'll just call this, again, we'll do age bins. That's fine. And then we'll group by these age bins, but do axis equals 1. And then calculate the total number of deaths by 10-year age interval. So dot sum. So there we go. All right, so these are the deaths by these 10-year age interval. Obviously, there's a lot more deaths as people get older. All right, then take this data frame and calculate the average deaths per group by 5-year time spans. Okay, so now we're gonna have this. We'll call it DF2. Actually, not tail. We want all of it. Now we want 5-year age span averages. So now we're gonna actually group the normal direction. So we need to get the year. Sorry, this is the index. All right, and then we're gonna cut this into 5-year age. Yeah, so we'll say 1980. And what we could do is use a range object here, say 1980 to 2025. Just so you can see what this is. We can list this out just so you can see the numbers. Actually, I need to go by 5. Okay, so here we go. Start, stop, step. All right, so we're gonna, these are the bins. So it doesn't, we need to make sure it includes 1980. So we'll just, the first one will have, we'll just leave the first one as 6. We can say include lowest equals true. So there we go. So from 1980 to 1985. All right, we'll call this S. And now we'll take DF2 and group by S and the mean average deaths. Okay, so there we go. So now we have our groups over here. And then we have the average deaths per those 10-year age intervals. So pretty cool. Definitely want to round this over here, get it a lot easier to read. All right, very nice. Okay, so that is it for these exercises.